Okay, so let's look at this page. We're going to be doing a little more with law of sines and law of cosines and distinguishing between them and then using both of them in conjunction. So real quickly, I figured let's go ahead and write ourselves another little sheet. So for any triangle, apparently I have a very acute triangle here. Triangle A, B, C. The opposite side of A would be little a, opposite side of B would be little b, and the opposite side of C would be little c. The law of cosines says that side c squared can be found by taking a squared plus b squared minus 2ab cosine of c, or if we were getting side b, that would be a squared plus c squared minus 2ac cosine of b. The way I have this memorized is that whatever letter is here, that letter doesn't appear anywhere in here except for it's the angle. So angle A, or side A, would be b squared plus c squared minus 2bc cosine of angle A. Then for law of sines, we would have sine A over A equals sine B over B equals sine C over C. Now, any of these ratios, there's three pieces to that. Of course, we break it into whichever two are the two that we are going to use. Now, when do we use these? Law of cosines, I tend to use when I have two sides and the angle between them. So if I have, I guess, put it over here. Law of cosines. We use that when we have two sides and the angle between. So that would be like if I was given side A and side B, and then I was given the measure of angle C, or if I was given B, C, and the measure of angle A, or if I was given A, C, and the measure of angle B. So it's anytime I have two sides and the angle between them, I have to use law of cosines. The other time I would have to use law of cosines is if I don't know that this is the right triangle, which would essentially mean I would know an angle was given, but they gave me all three sides. I need at least one angle to do any other calculation. So law of cosines can get us that angle. So if they gave me A, B, and C, I would use law of cosine. And then we would have to do an inverse cosine to get the angle. Now, law of sines is kind of easier because it's just a nice set of ratios that we can do a proportion, solve the proportion on it. So law of sines, we usually would need to have two matching pairs. I call it that, but so in other words, we would have to have measure of angle A and angle A, and then anything else, it doesn't matter. Measure of angle B and little b, and then whatever they ask for, it doesn't matter. Measure of angle C and little c, and then whatever they ask for. And then finally, if they gave me two angles, I can always use law of sines because I can use those two angles to find the third angle, and then after that, I'll be guaranteed a match pair. So that's the how and when we use them, and the formulas. So let's look at what we have going on here. So here they want to know whether we use law of sines or law of cosines. So here I have angle B, angle C. Actually, and as soon as I know I have two angles, I could find angle A, and then I could use law of sines. Law of sines. Here I have an angle A, and then I have sides B and C. That means those are the sides on either side of that angle. So that's going to have to be a law of cosines. Here I have an angle, and I have its side. As soon as I have that sort of matching, I can say law of sines. I have all three sides. I have no angles whatsoever. I'm stuck with law of cosines. Here, as soon as I have two angles, I know I can do law of sines. And that is everything for that one. Now, this is a sketch each triangle and find the indicated measure. I think I'm going to skip these ones to do these because these questions down here is we have to solve the entire triangle. So I'd rather do one of these where we have to solve for everything in there. But all of these, like you would have to find out like which, basically it's this up here. Actually, are these the same problems? No, they're not. But you would have to say, okay, here's angle A and side A. Oh, I get to do a law of sines to get, these are going to be two-step. Well, that's fun. We like that. Oh, they want us to find measure A. There we go. Okay. They give us all three sides. Helps if I read the problem fully. They give you all three sides, so we have to do law of sines to get, or law of cosines to get back to A. Here, they want to see, they gave us two angles. So we know we can use law of sines if they want. So we would have to get the angle A from these two, and then using A and this, we could find C. So anyways, I'm going to go ahead and get down to these ones because these will have to do, this is just to find one side or angle, and here on this one solve the whole triangle. So the same setup, instead of just finding one thing, we don't get to stop there, we have to find all of the pieces. So I think that will be good for us to do. Let's find a piece of paper. And I want one where I have to do an inverse sine, kind of. So let me see if I can find that. Yeah. I think 31 looks like it'll kind of suck. Let's do that one. Let's do number 31. So we have that A equals 27, B equals 25, and C equals 21. I'm trying to make this straighter. Okay, let's draw this guy out. So A is 27, B is 25, and C is 21. And it doesn't really matter which angle we decide we want to solve for. Oops, I got some bounce. Which angle we want to solve for first. So we'll just randomly pick one of them. Let's say we'll solve for C. So C squared equals A squared plus B squared minus 2AB cosine of C. And let's plug in all the pieces that we know. So C is going to be 21. And that's because that's across from angle C. And then A squared is going to be 27 squared. I'm also going to have a 27 over here. Since I'm using multicolors, we will toss that in now. Okay, I have blue, I have green. What's another color I want? Oh, okay. We'll use like a pink. This will be fun. And 25 squared and 25. And then right now my numbers look all kinds of crazy, but that's okay. Plus minus 2 parenthesis cosine of C. Okay. So you can say just plug these into their corresponding parts, and I put some color coding in there because, you know, colors are fun. And let's go ahead and simplify these on the calculator. So, oops, clear. 21 squared is 441 equals 27 squared, 729. Plus, I think that's 625. Yes, it is. 625 minus 2 times, oops, that's not times, that's minus, times 27 times 25 gives us, no. Let's try that again. Times. Ha! Much better. 1350, and then cosine of C. So now we need to solve for cosine of C. I guess I can add these two guys together. I forget how to do these when I do it by steps. I'm usually really lazy and I just make my calculator do all of it for me at once. But that's not good practice when you're doing this for the first time. So we'll be better behaved. subtract 1354 minus 1354. So 441 minus 1354 gives me, negative 913 equals negative 1350 cosine of C. So let's divide this guy over 1350. So I have to divide them because I have multiplication right there. And I think of that minus now as just being a negative. So divided by negative 1350 gives me a number. So I have that cosine of C is 0.6763. I would keep at least 4 decimals on these. I'm actually on the calculator going to keep all the decimals. So that's why a lot of times these calculators will have something like an answer button, which takes in the answer from the previous question. So I need to inverse cosine this, and then I'm going to show you how to do this in the calculator. So C is going to be, measure of angle C is going to be the cosine inverse of 0.6763. In the calculator, I'm going to go second cosine, and then I want that, I might be able to just arrow up there and grab it. Yeah, I can. So I was able to just arrow up there and grab it. And that gave me measure of angle C equals 47.445 degrees. Or if I just want this to 1 decimal place, 47 point, we're going to keep that as a 4 degrees. Now, another thing I could have done, let's say I had, I'm gonna backtrack this just a little bit. What did I have there? 1350. Okay, so anyways, here was my, here was that what I had that one answer in there. Oops, there we go. So I could have gone second cosine of, and then I could have hit second answer. And it tells it, the calculator, I'm going to put in whatever my answer was from my previous line there. And that would still give me the same thing. It does not work if you've done other calculations on there and it's like an answer like 3 lines back. But if, as long as the previous answer was what you want to take the inverse cosine of, you can do that. And then use second answer. So this calculator does let us scroll up and grab things, but if you were using, say, this guy, I don't believe he does. No, he doesn't. So, but he does also have that little answer thing. So I could have gone inverse cosine second answer, which won't work on this particular one because who knows what my previous answer was, but that would work. Okay, so that was a lot of work, and the sad news is we are not even close to done yet. But we have the measure of angle C. So that is great. There's a lot of work for this one problem. So up here, I can say C is, I'm going to redraw my triangle. And I think we're going to just color code it now. So I let A is green, 27. C, we now have the angle for, and the angle is 47.4. And that's 21. And then finally B, we don't know the angle yet, but it is 25. So now that we have this pair, we can use law of sines to find everything else. So I'm going to use sine of 47.4. Did they tell me what the nearest tenth? Yeah, they said round to the nearest tenth. I don't know if I would plug this in rounded. I guess we can. 4. Yeah, okay. And then 21. Now we can decide who we want to find next. So let's go with A. We don't know sine of A yet, but we know that this is 27. So I have this pair and this pair that I am using in law of sines to find the sine, to find angle A. So let's do our cross multiplying. Actually, to tell you the truth, I'm not even going to bother cross multiplying. I just want to get this guy over here. That will leave me with my sine A. So I'm skipping this. If I did cross multiply, I'd have to divide back over. So why do that? Let's just multiply. These cancel. So now I get that sine of A equals 27 times sine of 47.4 all over 21. And that looks pretty good, but I just want A. And I could multiply this in my calculator right now and get a decimal if I wanted right now. But yeah, I'll show you both. So I would say A is sine inverse, this is actually the measure of angle A, of that mess. Now, if having this big messy thing is really uncomfortable and your eyes are like, no, I can't look at that, you could have just put this in your calculator, gotten a decimal, and then just said inverse sine of some little decimal-y number here. I'm going to go and just put it all in as it is, though. I'll show you both, just because, you know, for funs. So, second sine, I'm going to go and put the fraction in there, which is that little button right there. So the top was 27 sine 47.445. I just extended it because I'm crazy like that. And then 21. So I have this looking like what's written there. And it tells me that sine of A, measure of angle A, is 71.279, or in other words, 71.3 degrees. Now, if I'd done this as a decimal first, I could have done 27 times sine 47.445, whatever it was that we had earlier. Yeah. Divided by 21. So I could have had a decimal here. And then I could have done second sine, and then I could have taken the answer, or I could have typed that in. I could type it in 0.9471, say I round it to 4 places, and I get, this will round to also 71.3. I'll have this is just some rounding error because of the differences in where I rounded things, but that's why to the 10th place they should match. Okay, that means that we now have, I lost my pin cap, we now have angle A. So I can write that 71.3 right there. All I'm missing now is angle B. I don't have to do any more law of anything because I can calculate that by just subtracting these guys from 180, right? So I can go that measure of angle B is equal to 180 degrees minus 71.3 degrees, woo, throw a pin, minus 47.4 degrees. And what do we get? We get 180 minus 71.3 minus 47.4. 61.3 degrees. Oh, we are pink. 61.3. All right. So we have now solved for all of the triangle that they were asking for. So what that means is that all these rest of these questions can be no harder. Basically, this whole section, that is the hardest possible problem you could have, where I had to do a law of sines with given all 3 sides, and then after I got that, I had to do a law of sines with an inverse sine. But it's knowing when to use which. The one that we like doing the most is law of sines. So something like number 27, we can just use law of sines to get everything. We wouldn't have to use law of cosines because they gave us 2 angles. So we're like, yay! For 29, we would have to use law of cosines first because they gave us 2 sides and an angle. 28 is just like 31. It's the exact same steps. For number 30, this is a law of cosines first. Law of cosines will give us side C, and then once we have side C, we can use law of sines to get one of the other angles. And then once we have the other angle, we can find the third angle just by subtracting from 180. So that's similar to the problem we just did, but a little bit easier actually. And then here for number 32, this is a nice easy one because they gave us 2 angles. So as soon as they give us 2 angles, just find the third angle, and then now we have C and angle C, and we use law of sines. Okay, I'm going to go ahead and end this one, and then I'm going to talk about a couple more on this page.